Okay, so in this video, I've already introduced trigonometry and what it is, the study of ratios. Now I'm going to actually teach you how to do trig and how to use these ratios. Again, your calculator is like a interactive book of ratios that your grandparents had to have, a table of values in a textbook. So you guys have this handheld calculator, or at least one on your Chromebooks, that can do this for you. So I'm going to come back over to our Smart Notebook and open up the notes that you're going to have in front of you. And let's kind of jump in here. So we're going to use sine, cosine, tangent ratios to determine the side lengths and angle measures in right triangles. The word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. So again, measures of triangles, really right triangles are the key here. And again, ratio. So the three most common are sine, cosine, tangent. Now, if I just kind of draw a triangle here for you, a right triangle, oof, let's try that again. That's better. Now we know that the hypotenuse is opposite the right angle, and the two legs are interchangeable in the Pythagorean theorem. That changes a little bit when you're talking about these angles. So when I look down here, I'm going to label this triangle ABC. This angle right here, angle A, the side that is opposite of it is over here. Now, the side that's closest to A, that's not the hypotenuse, is the adjacent side. That obviously changes if we're talking about angle B. If we were talking about angle B, then the opposite side would actually be this one, and the adjacent side would be this one. The only one that stays steady is the hypotenuse. Now, what about angle C? We don't talk about angle C because it's 90 degrees. It's not going to be something we worry about with trigonometry. So again, what we're going to do here is first we would label our triangle. So when we look at different relationships, we'll start with sine. So sine, and it's up here, is the measure of the leg opposite of angle A over the hypotenuse. So for example, if we had a 3, 4, 5 right triangle, right? It's a triangle that's a Pythagorean triplet. Then the sine of angle A is the opposite side over the hypotenuse. So the sine of angle A, is equal to the ratio 3 to 5. And the cosine of angle A is, if we look up here, the cosine is the ratio of the adjacent side to the hypotenuse. So the adjacent side for angle A is 4, so it'll be 4 over 5. And finally, the tangent is the opposite over the adjacent. So tan A is going to be the opposite side of A over the adjacent side of A. So 3 over 4. And likewise, we could do the same thing again, this time with angle B, where the opposite side is going to be here and the adjacent side is here, and the hypotenuse stays the same. So when we do sine of B, our opposite over our hypotenuse is going to be 4 over 5. The cosine of B is 3 over 5, and the tangent of B, which is the opposite over the adjacent, is 4 over 5. So you can see that, A and B have different sines, cosines, and tangents in this triangle. And again, we can understand that this might be useful because we don't know what angle A is. We just know the measurements of the triangle that are given to us. But where trig is really powerful is when we don't know one of those measurements, but we know the angle measure. So we're going to do that next.